Hello everybody, welcome back. Today we'll be reviewing K76 problem 3. So the exercise wants us to find the common points between these two graphs, so intersection points, and we need to confirm the answer by drawing the graph. So our first graph seems like a quadratic or a parabola because our highest degree term has a power of 2. And then in this case, this graph is a line because this follows the form of y equals mx plus b, which is a linear line. So the first step I'm going to do to solve the points of intersection is I'm going to set the two y coordinates equal to each other. So I'm going to set x squared minus 4x plus 5 equal to 2x minus 5, because this is done under the assumption that if there are indeed points of intersection, I should be able to plug that x point of intersection, the x value of the point of intersection into both sides of the equation and get the same y value, right? Because that's what a point of intersection is fundamentally. It's a point that is shared by both of the graphs, right? So I'm going to go ahead and solve for this equation by subtracting 2x on both sides and adding 5 on both sides, because I just want to get everything on the left-hand side of the equation. So I'll get x squared minus 6x plus 10 is equal to, this side is equal to 0. And now I want to solve for what values of x will give me 0. So essentially I'm just solving for the roots of this equation. So seems like this isn't factorable, and that just comes with like familiarizing yourself with a bunch of quadratics. So yeah, but if you tried, you wouldn't be able to factor this. So instead I'm going to try to use the quadratic equation to solve for the roots. And then it seems like there's a shortcut that I can use for the quadratic equation, because in this case our coefficient for x is even, because -6 is even, so I can use this equation. So in the case that you have an even x coefficient, you can use, so the roots are equal to -b/2 plus or minus the square root of -b/2 squared minus ac over a. And then so I'm going to go ahead and use that. So the roots are equal to -b. So b in this case is -6. So the negative version of that is just +6. Put that over 2 is 3. Plus or minus -b/2 squared. Well, we know that -b/2 is 3. So square that, you get 9 minus a. A is the coefficient of your x squared term, so 1. So 1 times c is the constant, so 10 over a. So a was just 1. And we get 3 plus or minus 9 minus 10 is -1, and I know that the square root of -1 is I. But this kind of strikes out to me, or sticks out to me, because if you get an imaginary root, then that means that you have no real solutions, meaning that on the 2D xy plane, there actually are no visible common points between these two graphs, since I did not get any real solutions. If I got real solutions, then I would have visible intersection points, but in this case these are imaginary solutions, so I don't have any visible common points or intersection points on the 2D plane of these two graphs that I was given originally. So I'm gonna say there are 0 common points, and then I can confirm that this is correct, that I didn't make a mistake, by calculating the discriminant of this. So in the case where your b term is even, I have a shortcut for the discriminant formula, and then I just say d/4, because that just means I'm applying the shortcut for the discriminant formula, and that formula is going to look like b/2 squared minus a times c. So that's b is just -6, put that over 2 is -3, square that, so 9 minus a, 1 times 10, just c. I'll get -1. That is indeed less than 0, so I can confirm that I correctly have 0 common points and no real solutions. And they want us to confirm the answer by drawing the graph, so I've actually put these two graphs on a graphing calculator. Shout out Desmos. And as you can see, there are no visible intersection points because we're looking at a 2D plane, so there's no intersection points between these two graphs. But for the practice, you may have to manually or draw these out by hand, but just make sure that you don't draw any intersection points. But the graph doesn't have to be exactly perfect. You can just graph like a couple points for the parabola and graph like 2 points for the line, and that should be sufficient. And yeah, that's it for that one, for this practice at least. So yeah, good luck, take care. All right, bye bye.